Mole concept. There is a concept of thermal energy TE and intermolecular force. If you heat the substance, you know distance will increase, intermolecular force will decrease, and thermal energy will increase if you heat up. So in gas, you know distance is more, so thermal energy is more. In solid, particles are very close to each other, so intermolecular force is more. Atomicity, number of atom in a molecular compound. Whenever you write any atom, below you write atomic number Z and above you write atomic mass A. Atomic number is equal to number of proton. Atomic mass proton plus neutron. Jordan, is number of proton always equal to number of electron?
Number of protons is not always equal to number of electrons. It could vary.
In ground state, it is always equal, but in the ionic form, it is not.
Yes, sir.
Okay. If you see the mass difference between the proton and neutron, so Hina, what is the difference between these two? Proton and neutron mass difference. Which one is heavier?
So proton, no, neutron.
Neutron is little bit like one will
Just
be
yes, sir.
1.672, another will be 1.674, something like very small, negligible difference, but neutron is slightly more, slightly, right? If we want to calculate what is the mass of one atom, mass of proton multiply by atomic mass. Okay, and usually it is written in the atomic mass unit. You know isotope, same atomic number, different atomic mass, but chemical property are same in case of isotope. Chemical property same. Chemical property same, extremely important this point. But physical property is different. Example, carbon C12 is highly stable, but carbon 14 is isotope, radioisotope. Correct? Radioactivity will be there. So physical property are different, but chemically more or less it is same. Average atomic mass percentage mass multiply divide by 100. How? Example, if you take these two, what will be the average atomic mass, Chandana, in this case? Chandana, what will be average atomic mass in this situation? 85% of boron 10 isotope plus
So one question, sir.
15% of 11 divided by 100. Yes, Jordan.
So are we supposed to copy this down in our notes, sir, from the beginning?
Not really. Just read it quickly.
Okay, sir.
Okay. So by this, if you calculate the average, what will be average? 850 plus what is the value? 10.15, right? That should be the average atomic mass. That's how you calculate. You add all the value with their abundance, multiply with their abundance, 85% multiply by atomic mass plus 15% multiply by the atomic mass divided by 100. Any doubt, guys? How to calculate abundance? Because you get question like this. Isobar, you know about this isotone, number of neutron are same. Isosters, when atomicity is same and same number of valence electron. This is important. Same number of valence electron. Mass of one atom. Example, if you take for oxygen, here it is O oxygen, it is 16 AMU, and one atomic mass unit is fixed like 1.67 into 10 raised to power minus 27 kg. This is the mass of one proton. Okay. So 1 mole contain this number of atom or molecule, which is also known as Avogadro number. One atom mass in AMU, one mole mass in the form of gram. Example, if you take what is the mass of one H2O molecule, then it will be 18 AMU. But if you take one mole of H2O molecule, then it will be 18 AMU. But if you take one mole of H2O, then it will be 18 gram. Okay, you might make mistake in this part. So one molecule mass is different, one mole molecule of mass is different. Okay, same thing is given here. And whenever you will see this word gram atom, it means we are talking about moles. This is one of the most popular formula from this whole chapter. How to calculate moles. This form, given mass by molar mass, or given number of atom by Avogadro number, or given volume by 22.4 liter, or same thing in form of ml, or remember 1 ml is equal to 1 centimeter cube. That's why number is exactly correct. What is standard temperature pressure? Standard temperature 0 degree Celsius, standard pressure 1 bar. And nowadays we use this part. But still, for most of the calculation, you can still use 22.4 liter, depend upon what is given. Vapor density, given mass of any gas divided by 2. Why 2? Because hydrogen. We are using hydrogen. Next, Barinder, what is law of conservation of mass? In a given reaction, mass of the reactant is equal to mass of the product. Mass of the reactant will be equal to mass of the product. Example, if you take 12 gram carbon and 32 gram oxygen, it will form product CO2. Mass is still 44. If you combine both of them, it remains same. This law of conservation of mass was given by Lavoisier. Pratigya, what is law of multiple proportion given by Dalton?
Any
Pratigya,
of the element is
any of the element?
atomic mass fixed mass या फिर
When
number.
when we take any molecule and one atom is fixed, another is changing, they will change in the simple whole ratio. Here, nitrogen and oxygen are present in 1:1 ratio. Nitrogen oxygen 1:2 ratio. Nitrogen oxygen 1:3 ratio. It will be present in the whole ratio. Hmm. Law of definite proportion or equal proportion given by Proust. He said whether you take artificial material or natural material, material will remain same. Example, if you take artificial water or natural water, both water will have H2O composition only. Hmm. Gay-Lussac law, when pressure and temperature is same, volume directly depend upon the number of molecule. More number of molecule, more volume. Correct? More number of molecule, more volume. Anvita, what is the difference between the empirical formula and molecular formula? Anvita, what is the difference between the empirical formula and molecular formula?
Sir, I don't know how to explain like properly. I don't even remember the whole thing.
If you take the what exact thing, whatever you have, example glucose. If you take glucose, you will write glucose in the exact form C6H12O6. But if you divide with a common number and get the simplest basic form, that will be empirical formula. 36H12O6 is molecular formula, real, whatever is present. But if you divide in the simplest form, you can divide the whole number by 6. So whatever value you will get is the empirical formula.
So empirical formula will be the formula for like the actual number of atoms in the chemical, but then molecular formula will be the simpler
No,
form.
no, no. Actual is molecular.
Okay, I
Empirical
became
is
straight up.
the basic one.
The basic one is molecular formula, and the very simple one is empirical formula.
Yes.
Okay, sir.
How question will be asked? It will be like carbon percentage in a compound is 48%. Hydrogen is 4%. And the number of element present in a given compound is carbon, hydrogen, and oxygen. You have to find out the empirical formula. How to do? First, divide the percentage with the atomic mass. First, divide by the atomic mass. Whatever number you will get, if you want to divide further, you can divide with a common number. Example, if you get 448, if you get 448, you can divide with a common number 4. Make sense? But here it is already present in the simple whole ratio. In case if you get 448, you have to further divide with a common number. 4 ones are 4, 4 ones are 4, 4 twos are. In that situation, it will be C1H1O2. It will be like that. Understood, guys? Any doubt?
No, sir.
Hmm. So next is the what is the minimum molecular mass of a compound? Atomic mass divided by percentage of element. It is ulta. Okay. Next, you already know all these things. Uh, so first is weight by weight. So weight by weight. Example, if you have NaOH in gram and total water in gram, so it is weight by weight. Same thing, volume by volume. Same way, weight this mass weight by the volume. Nothing special because exactly same stuff is given in class 12 solution chapter. Am I right? Am I right? Example, if it is written 20% of weight by weight of NaOH, it means if you take total 100 gram, 20 gram is NaOH and remaining 80 gram is water, total is 100. So what is the solution mass? 100. What is the mass of NaOH? 20. You can calculate weight by weight. Understood, guys? Anybody have doubt?
No, sir.
If you write like this,
No, sir.
you have 10% volume by volume of HCl in ethanolic solution. It means not 100%, 10%. If you take 10% volume by volume of HCl in ethanolic solution, it is saying that you have 10 ml of HCl within solutes. Okay. In ethanolic solution means 10 ml is HCl, 90 ml is ethanol. Solvent ethanol C2H5OH total is 100. If you calculate volume by volume percentage, how to calculate for HCl given mass? Total mass is 100 divide by multiply by 100. This is how you calculate percentage. Any doubt? Nobody will ask you direct question. It the question will be asked from your solution chapter while you are solving your mole fraction. There you will utilize this. Okay. There you will utilize this. Give me. So purity concept. Remember, purity concept is applied to the reactant. So purity concept is always taken for the reactant. Okay. Example, if it depend, what is the purity or impurity concept? Mass of the pure reactant divided by the total reactant mass multiplied by hundreds. In same way, you can calculate impurity concept also. Got it? Same thing is written here. Example, you take 22 carat gold and pure gold is 24 carat. How to calculate purity? 22 carat divided by 24 multiplied by 100. What will be the value? 2200 divided by 24. Let me calculate. It will be 2200 divided by 24. It is 91.6. And if you remember, how many of you have purchased gold in your life?
One time.
One time. Have you seen this number
Yes, sir.
916?
I don't remember.
See, you are not aware about the mole concept and solution.
No,
That's why you
sir.
don't remember.
I was in the sixth grade when they're doing it, so I just
Okay. Because I recently purchased, so I got to know if whenever you check purity of the gold and mark of the like proper quality, like whether you purchase Kalyan or you purchase from the Tanishq or any other brand, you will see 916 purity. I will show you. 916 gold is 916, see, 22 carat gold. 900 gold, a proportion of 91.6 gram, pure 24 carat in 100 gram of alloy. This is how we calculate percentage, mass by mass, and you can check purity, 22 carat. Got it? And you will see images. See, this is how this hallmarking. This is purity. Understood? 916. So this is showing purity of the compound. Same way you can calculate impurity. Given impurity by total mass. Yield concept is always applied to the product because yield means product, how much product is. So actual yield, what was theoretical and multiply by 100. Correct? So you can calculate yield. Example in this case, this is the number of mole. Correct? Given for the situation, you should know what is the given value, and based on that you can calculate.
So can I join in 5 minutes?
Then I
Join
do
in
you need
5 minutes.
explanation? Okay, you can join in 5 minutes, sure.
Thank
Because remember, you won't understand much, but while I will explain you the numerical, you will get to know ki, okay, I've done this before. I have some basic idea how to calculate. I think one of the issue you face in this chapter is limiting reason, nothing else. Am I right? How many of you face issue in limiting reason?
Numericals, I get like little, like I get confused.
Okay. So raise your hand, guys, if you face issue in the limiting reagent. Pratigya, Barinder, Jordan, Sara. Okay, Barinder, you don't face issue. Okay, so Chandana is not there and Tuhina is not there. Okay, so let me explain you how to calculate in the easiest way, though it is already given here. To calculate the limiting reagent, you should know the equation first. Example, this is the equation given. It says that if you have 1 mole of N2, there should be 3 mole of H2. It means if you take 10 mole of N2, there should be 30 mole of H2. But it will be given to you that you have only 10 mole of hydrogen with 10 mole of nitrogen. It means hydrogen should be 30, but actually it is only 10. It means you have shortage of hydrogen. That's why shortage thing is known as limiting reagent. Tell me guys, anybody have doubt now? For this, you should know this 10 mole of nitrogen and hydrogen. It will be given in the question. 10 mole will be given in the question. Got it? If we don't have this number 10 mole of nitrogen, 10 mole of hydrogen, we cannot calculate limiting reagent. Just by equation, we can't. We need two things for limiting reagent. One, your equation. Second, the given value, like 10 mole. Example, it should be 30 mole for 10 mole of nitrogen. Hydrogen should be 30 mole. But if it gives 40 mole, then hydrogen is present in excess. It means nitrogen is limiting. If hydrogen is excess, then nitrogen will be limiting. Done. Understood, guys? Anybody have doubt? So limiting reagent means reagent where we have shortage of the compound. Okay. Mole fraction you already know, given mole by total mole. Molarity, moles of the solute divided by volume of the solution. Moles of the solute divided by volume of the solution. Yes, this concept is extremely important because I know where you might face issue in this concept. Whenever you do dilution or you are concentrating the compound, what will remain same? During dilution or concentration, what will remain same? Number of okay, number of moles will remain same. Example, you take a container in which you have 100 gram of sugar. Okay, 100 gram of sugar. So there will be fixed mole. Now, after dilution, you add 5 liter water in this container. Already you are having 2 liter water and further you add 5 liter. What will happen? Amount of the substance means amount of your sugar remains same. So it means mole will remain same. What will change? Molarity will change. Volume will change. What remains same? Number of moles. That's why number of moles is equal to molarity into volume will remain fixed. So if you are diluting or concentrating and keeping the amount of your solute fixed, only then you can apply this formula M1V1 is equal to M2V2. Why? Because all of you know this formula. Formula is easy, but many people don't know when to apply this formula. When you are doing dilution or concentration of the compound. Because your solute remains same, everything remains same. Any doubt? Next, Sarah, what is molality? What is the difference between
Um,
molarity and molality?
so molarity is number of moles uh, per no. Molality is number of moles per liter,
Hmm.
like in 1 kg. Molality.
Hmm. Okay. And molarity?
Uh, Number of solute. I don't know some molality. Got.
So all these things are given in the solution chapter of exactly same. Molarity is number of moles of solute divided by volume of solution in liter. While molality, where this is what we have in elevation of boiling point or depression in the freezing point, number of moles of solution remains same. Here below you have mass of the solvent in kg. So in molarity, you have volume of solution. In molality, you have mass of the solvent. Mass of the solvent. Mass of the solvent. Okay. Then strength of the solution. Instead of moles, you are using mass of solute divided by volume of the solution. So it look like molarity, but here we don't have moles. We have only mass of solute. Okay. Anything else? No, I think most of the things are done. This is the quick revision of the same chapter. Done. Now we'll solve question. I will tell you 2-3 questions properly with more detail, and after that you will solve question. Are you ready for question, guys?
Yes, sir.
First question. Dalton atomic theory could not explain about which of the following. You have 4 options. Law of multiple proportion. You know this law of multiple proportion was given by the Dalton. Gases law, Gay-Lussac law of conservation, Lavoisier, and law of constant proportion. Definite fixed proportion was given by the Proust. So in this case, answer will be second. Gaseous law are not explained by the Dalton atomic theory. Okay, remaining thing were given earlier: definite proportion, multiple proportion, and law of conservation of mass. Okay, so based on that, Dalton atomic theory, copy, here will paste. So because next time they can ask any of this, कि Dalton atomic theory explain which of the following. So you can delete this part. Why? Because theoretically everybody teach this Dalton atomic theory explain कि um, every element will have exactly same nature of the element, same number of electron, proton, and neutron, and all the stuff. So Dalton atomic theory explain these 3 important concepts. Next, you have to choose equal number of atom in each case. Equal number of atom. How to calculate? Given mass, total number of moles, given mass 212 by molar mass. Molar mass of this compound is 106. So total number of moles will be 2. Here 248 divided by 62, it will be, what will be the molar mass? It will be 4. Here 240 divided by 46. Here 12 by 2, 6. Here 220 by 44, 5. I guess. Yes. Is this correct, Jordan?
No, sir.
Why? I said 2, 4, 6, 6, and 5. Why this is wrong according to you? Chandana, is this correct?
So shouldn't it be the other way around?
No.
I-
Here we are talking about atoms, not the number of moles. It is the number of moles of overall compound.
Sir, I
Now
need to
you
add
have,
about a number, right?
we have to consider the total number of atom in each compound. Here you have two Na, one carbon, and three oxygen. So total six number of atom. So if you take moles of atom, then you will multiply by 6. Total will be 12. Here, 2 sodium and 1 oxygen. Total 3. So multiply by 3. Here total number of atom 4. No, sorry, 3. 1 sodium, sorry. Yeah, 1 sodium, 1 oxygen and 1 hydrogen. Total 3. Here 2 hydrogen and here 1 carbon, 2 oxygen. Total 3. So multiply by 3. Now tell me where you have equal number of atom. A is 12, B is 12, and D is 12. Your answer should be ABD. Yes or no, guys? Make sense? Anybody have doubt? Ask your question. In first few question, you are supposed to ask everything, whatever you don't understand. Anybody have doubt?
No, sir.
Remember, first you will calculate total number of moles. Once you get number of moles, then multiply with number of atom. First, I calculated total number of moles in Na2CO3 is 2. Then I checked what is the total number of atom in this 6. So total value this. Same in second, total number of moles is 4. Atom is 3. 4 3 is 12. Any doubt, guys? ABT.
So can I
And
watch the recording? I'm really not feeling well.
okay, sure.
Thank you, sir.
Yeah. Next, guys. Amount of glucose required to prepare 250 ml of this aqueous solution, molar mass. In this case, molarity is 1 by 20. Amount of the glucose you have to calculate. Glucose molar mass is 180. Volume of the solution 250 ml. You have to calculate amount. How to calculate? Molarity is given mass divided by molar mass 1000 by volume of solution in ml. This is the formula. What is the given mass? We have to calculate molar mass 180, 1000 divide by 250, 445. So 45 divided by 20. Tell me guys, anybody have doubt? Simple molarity formula. Yes or no? Because after five question, if I get a similar kind of question, I will ask you. You have to explain. So ask your question. See, we this question is repeated. So Anvita, tell me your answer with complete explanation. 1 gram of H2 have same number of molecule as in. What is the number of moles in 1 gram of H2? Any doubt? Tell me what is your answer and why, Anvita.
Can you repeat?
Answer of this question. What is visible on the screen?
So, can I
Yeah, Jordan.
answer?
Be ready with your answer and explanation in every question. What is the number of moles?
Okay, sir.
Hmm.
Just see.
See, if you look at A option, given mass is 14 and molar mass is 28. So this is zero point 0.5.
Wait.
Right answer will be A.
Yes, yes, sir.
Second case, given mass is 18, molar mass is also 18, 1. Here given mass 16, molar mass 12 plus 16, 28. And here
So option B.
20, 28, it is 1. So answer will be A.
Wait, how, sir?
What is the
Two is supposed
number
to be
of moles in
14.
what is the number of moles in 1 gram of H2? Half. What is the
Yeah.
number of moles in 14 gram of N2? Half.
Okay, I was doing the okay, I did the opposite way, yes, sir.
Yes or no? Remember,
Yes, sir.
here we are talking about molecule, not atom. So don't do atom thing. You don't need to do this. This is from the different chapter. Jordan, sixth question.
1 minute, sir. So option B,
Option B.
250 milligrams.
So 1 gram of NaOH treated with NaOH HCl H2. This is the reaction because NaOH react with HCl. What will happen? NaCl and H2.
It's 1:1, so it's equal
So
to 0.
1 gram is equal to 1000 mg. 1000 mg. When 1000 mg react with 25 ml of 0.75 mole of HCl, first you have to calculate what is the mass of HCl. So you use molarity method because molarity is given 0.75 is equal to given mass. What is the molar mass of HCl? 36.5.
Yes, sir.
1000 divided by 25 ml. So you can calculate what is the given mass of HCl. Right? Now you will compare and you have to find out which one is the limiting reagent. Mass of NaOH is left unreacted equal to, it means HCl will be limiting reagent and NaOH will be present in axis. That's why it is left untreated. Okay. If you take 1 mole of NaOH, react with 1 mole of HCl, it will produce 1 mole of NaCl and 1 mole of H2. Correct? This is the ideal situation. If you take here 40 gram, 1 mole is equal to 40 gram, it should be 36.5 gram, right? And you are already saying कि HCl is limiting reagent. How do we know? Because NaOH is present in axis. See, NaOH left unreacted in axis. Okay. So, what is the value from the question, Jordan? What is the value from this?
So I got 0.025.
0.025 means 250 mg.
250 mg.
So, if it is 250 mg, it means 250 mg of NaOH will be utilized. What will be the remaining out of 1000? 750.
750. Oh, okay, that's okay. Okay, yes, I just calculated 250 and I thought that was the answer.
Now, I don't know. You have to tell me calculation. What is the answer?
So it should be 750 mg then, so because I got 250 till this, I didn't do the subtraction from 1000.
But I guess if you subtract it, it won't be 250 mg. It should be 750 mg. I guess
My
from the calculation.
calculation wrong after check.
Yes, your calculation is wrong. If you get the calculation 750 mg of HCl, it should be around 750, around, because 36.5 gram HCl utilize 40 gram of NaOH. If you take 750, you will get slightly more. And based on that, there will be only one option available. Check it. You need to do calculation in this chapter. All of you understood, or should I explain this again, guys? Let me know.
So can you explain it
Sham.
again? So I think
Yes.
somewhere I went wrong.
Yes. NaOH react with HCl. This is given in the question. NaCl plus H2O. First thing, according to the question, it is saying कि NaOH is left unreacted. Left. It means this HCl will be 100% consumed. Whatever is 100% consumed in the reaction is known as limiting reagent. Okay. Based on the molar mass, you know if you take 1 mole of NaOH, it will utilize 1 mole of HCl. If you take 40 gram of NaOH, it will utilize 36.5 gram of NaCl based on the molar mass. Correct. Now, according to the question, 25 ml of 0.75 mole of HCl is given, molarity is given. So, based on that, you can calculate what is the HCl amount given. What is the HCl amount given in mg? Because all of your option in mg. How to calculate? Molarity formula is given weight by molar mass 1000 volume of the solution. Molarity is 0.75. Weight of HCl we have to calculate. Molar mass of HCl is 36.5. 1000 volume of the solution is 25 ml. This is 40. Okay. If you do calculation, let me use calculator. 0.75 multiply by 36.5 divide by 40. You will get around 684 mg. Okay. This is given in here 684 mg. How now you will use what is the method, Chandana? Ki if 36.5 gram of HCl produce 40 gram NaOH, then 684 gram HCl will produce how much NaCl? Sorry, NaOH. 40 divided by 36.5 multiply by 684. What will be the answer? 40 divided by 36.5 multiply by 684, around 750 mg. So 750 mg will be utilized. 750 mg will be utilized. Total amount available according to the question is 1000. 750 utilized. What is the amount remaining left unreacted? Any doubt? First calculate what is the amount of HCl given in the question. Based on that, you can calculate how much NaOH will be utilized. Example, here total amount of NaOH available was 1000, out of which how much consume? 750. What is the remaining? They are asking remaining 250. Make sense, guys? Now tell me, how many of you have doubt?
No, sir.
Sarah, any doubt in this question?
No, sir.
Chandana?
No, sir.
Barinder?
No, sir.
Pratigyanita?
No, sir.
Because I still remember last time when I taught this, all of you took time to understand this, and it happened. You need practice. Key how to do it quickly. First, calculate HCl amount. Second, based on the Chandana, what is the method? What is the name of this method? What? What? What is this mathematical form where using one number you calculate second like this? Number method or something else?
No, sir. I'm not sure.
Okay. So you know 36.5 gram produce consume 40 gram annually. 684 mg will use 750 mg. Utilize this much. What is the remaining? 1000 minus this. Done. Pratigya, tell me this. Highest number of helium atoms. What you are supposed to calculate in this, Pratigya? Calculate क्या करना है तुम्हें इसमें? Highest number of atom will be present in the maximum moles. Correct. In first option, already number is given 4 mole. Second case, 4 unit of helium divided by molar mass 4. It will be 1 mole. 4 gram of helium.
Answer A.
And last, so what will be the answer? A. Any doubt? You have to calculate moles. More the number of moles, maximum will be the number of atoms. Example, 1 mole contain 6 into 10 raised to power 23. 4 mole will have 24 more. Anvita, empirical formula.
So can you help, because I get confused in empirical formula questions.
See what is the percentage? Divide by molar mass. Here number of moles will be 0.5. Second, B, percentage is 20. Molar mass is given 40. So 0.5. C, what is the remaining? 32 plus 20, 52. Remaining is C. It means 48. What is the molar mass? 32. So it will be 3 by 2. So it's like 1 by 2. This is 1 by 2. This is 3 by 2. If you multiply everything with 2 to get the simple whole number, it will be 1. It will be 1. It will be 3. 1, 1, 3. Do you have option? Any doubt, Amrita?
No.
First, write what is the percentage given. Then divide by the molar mass. Get moles and take simple ratio. Last value is 3 times of first and second. Done.
So why did we multiply by 2 again?
To get the simple whole number. Otherwise, you'll get confused in the calculation.
Huh.
To get the simplest number, you have to see purity in this case, Chandana.
Yes, sir. Sir, I'm not getting the answer.
You know,
So,
according to yes, Jordan.
option 1, 1.76.
Let's see. This is the equation. If you see in this situation, what will happen? Molar mass of calcium carbonate is 100. Molar mass of CO2 is 44. Correct. And 20% of pure limestone. It means if you have 100 gram, then only 20 gram will be limestone calcium carbonate. One fifth. Correct. If you have total 20 gram, one fifth will be 4 gram the pure calcium carbonate. Makes sense? One fifth.
Yes, sir.
Any doubt? This is the calcium carbonate amount you have. Second, if 100 gram of calcium carbonate will produce 44 gram of CO2, how much CO2 will be produced from the 4 gram? Was it really difficult, guys?
No, sir.
You need to know what is the pure amount of calcium carbonate you have, because 20% purity. Any doubt, guys? Anybody?
No, sir. No.
Huh. Next, who will answer? Barinder. Density of 1 molar solution of X compound is this. Correct option of molality if molar mass is this. If molarity is 1, it means you have 1 mole
Sir, option D.
in 1 liter of solution. 1 liter of solution. Option D. Okay, let me check. So if molarity is 1, it means 1 mole in 1 liter of solution. And density is 1.25. You know density is equal to mass by volume of the solution. So you can calculate mass by using this. So mass will be density into volume. What is the density? 1.25. What is the volume of the solution? 1 liter. So your molar mass will be 1.25 or 250 gram. This is the total mass of the solution. Correct? This is the total mass of the solution. What do you need to calculate? 1 mole. 1 mole of this will be 85. 85 gram of X substance. This is the amount. What will be the mass of the solvent? 250 minus 85. 1165 is the solvent mass. Now you can calculate what is the molality. Moles of solute, that is 1 by mass of the solvent 1165 multiplied by 1000. Understood, guys? So let me explain what you need to do in this question. You have molarity. So through molarity, you know 2 things. Number of moles is 1 and volume is 1 liter. Second, using density, which is equal to mass by volume, you can calculate mass of the solution. Density into volume. हाँ, तो नजर कर दी है कि क्या है? रुक जा, बस 5 मिनट रुक जा. So you will get mass of the solution. Once you get mass of the solution, you know solution made up of 2 things, solute and solvent. Why I'm bothered too much about this? Because in my molality topic, बस 2 मिनट रुक जा. In my molality topic, I need solvent mass, not total. I need solvent mass. How do I calculate? I need to know what is the solution mass total, what is the solute mass. So solvent will be solution minus solute. That's what I did. 1250 is the solution, 85 is solute, and this is solvent. Ask me, guys, your doubt. So, Varinder, your answer was correct, but everybody understood how I did this, or anybody have question?
मैं चले गया जब स्कूल में तो निकली
Anybody have doubt, guys? Though there is a method, there is a formula many people teach you in your coaching institute. कि molality formula is रुक जा 2 मिनट खत्म होना हो रहा है. Many people will teach you molality formula is 1000 multiply by molarity divide by 1000 density minus molarity and molecular weight. But trust me, never use this formula. One of the most dangerous formula. Never use it. Why? First thing, you won't be able to remember it perfectly. You might make mistake. You might make mistake. If you use the basic method, first molarity, second density, and third molality, then it will be easy and simplest way. You don't need any extraordinary formula to remember this. Make sense, guys? Because once you finish the full syllabus, memorizing this formula will be difficult. Am I right?
Yes, sir.
Let me know, guys, if you have any doubt. Got it? Anybody have doubt, guys?
No, sir.
Good. So from this chapter, you always get easy question, but little bit lengthy calculation sometime. So how much you will finish in today's part? 30 question is okay, not too much. By 11 o'clock,
Yes, sir.
30 question by 11 o'clock, you will get idea about the question. Remember, you will use always the basic thing. What is molality? What is molarity? What is mole fraction? What is number of moles? How to calculate number of moles? What is the role of limiting reagent? If you know these few things properly, trust me, your chapter is done. You need only these part, nothing. Limiting reagent, number of moles, mole fraction, molality, molality, and their basic formula and basic math. Example: even in this question, if you are calculating number of atom in 0.1 mole of triatomic gas, Na is this. What are you doing? You are calculating Avogadro, like using Avogadro number, total number of moles is given. Number of atom, you know, one mole have 6 into 10 raised to power 23 atom. Same formula of this N, number of moles. Nothing else. So theory of this chapter is easy. You have to solve too many questions, especially for the calculation part, to make it fast. Okay. So by 11 o'clock, you will finish 30 questions and you will send me in the group. I will be awake by then and I will check all of your explanation. I already sent PDF in the group. You have to use only this PDF. Got it, guys?
Yes, sir.
Yes, sir.
Yes, sir.
PYQ. That's all. Do it properly and let me know your doubt. I will cover doubt in today's class only. Okay, I'll take one more session at 11.